and get started with this conversation. So today we're going to be looking at building on what we talked about last week, and as part of our energy, or part of our plan review series to support energy code compliance, we're going to be looking at energy plan review for mechanical systems. For those of you who aren't already familiarized with who we are what we do. We're the Minnesota Energy Code Support Program. My name is Josh Harmon. I'm with Shumscode Associates, and we are supporting this organization alongside the various municipal utilities across Minnesota to really support, educate, and empower both building professionals throughout the state in the process of constructing energy efficient buildings. So that's really our goal. And so there are other resources and technologies, things that we could do. Please let us know how we can better serve you. So I'll throw that in there one more time, the handout, so everyone has that as we start the conversation. So if you do have questions along the way, always feel free to check out our Minnesota Energy Code Support website. Up in on the upper bar, right, you'll find a section that talks about technical documents. In that technical document section, you'll find different resources like our inspection guide and some of the other resources. One we're working on right now, it's fresh on the block, is our look at creating an energy plan review guide. So that way we can, it's really trying to not necessarily take away. We've provided you have access to both our relationship with Minnesota Center for Energy and Environment, the an Excel-based checklist or design guide for plan review. But I think this is just our way to even, I'm going to say this the way I like it, make it a little bit even more simplistic and a little bit more understandable and readable to help guide. It's not to be a checklist, but to be a guide in using both the checklist that exists as well as how to better understand what we're doing. Because my feelings. If you understand the why, then you can figure out the how, and then with the how, we can figure out the what. And so some of the other resources that you'll find on that website, again, are going to be our review or our guide on commercial HVAC calculations. Kind of what is 180, 190, 183, 183. What is 183, ASHRAE 183 trying to do? Where do you normally see this show up in most designs? There are some prevailing methods and systems for HVAC load calculation documentation. Try saying that 3 times real fast. And what we find is, again, what are some of the ways we see those come out, and what are we looking for in them, which is kind of the basis of what we're doing today. And you'll also, again, find a link, as well as I think there's a PDF copy of the plan review checklist that was developed in partnership with Minnesota Center for Energy and Environment. And in that's really designed, in my opinion, to kind of help guide the designers in preparing a set of documents that can go to plan reviewers, right? So they can go through the process, and I'll use my handy dandy highlighter because I love that laser pointer so much. And so as they go through, they can start to identify their compliance path, and as they check through certain boxes, it starts to eliminate things that aren't necessary. So if you choose a compliance path, then it'll modify what you're expecting. So here we see a little screenshot of some of the different mechanical HVAC components, the questions they ask, and then again where they can put a note for us as plans examiners to say, let's look at the first one. For buildings following the simplified approaches, the building 2 stories or fewer in height and less than 25,000 square feet of gross square feet. So it gives us the code section, and then we can put yes, see page 1.0 or something of that nature. So then we can go through. The concept is that you would go through as a building official and say, or as a plans examiner, say yes, no. You could use their checklist as a way to help facilitate that. And then also gives us some potential comments, correction comments, if a jurisdiction want to do that. Again, those are resources that are online available to you. If you have questions about it, always feel free to reach out to us. We will walk you through, show you how they work, what they're intended to do, and how we would probably see using them. Again, we're just one person or one team of people trying to facilitate. As we often say, we're the authority having jurisdiction nowhere, right? So we can say things that maybe you will or maybe won't employ in your process. But again, there's just some different things that show up. Again, they're broken out by compliance types, as well as if someone's using prescriptive versus performance. So if we have questions at the end, I've got some more slides associated with that. I've got the checklist on my computer here. We can show those and talk about them. But again, it would be easy to say, are the temperature maintenance controls in place as required? Right? That's where they're getting at. Yes. And where? Right? Those are the questions that we see being asked. Thought I saw the hand, but maybe not. So again, if you have questions along the way, feel free to pop them in the chat, put them in the, raise your hand. We can always unmute you. We can chit chat through the process. So those are the resources that you can find to help facilitate the conversation we're having today, which is why. Why do we even care, right? Well, the reason we care is because we have codes that say we care. Codes say we care, and we're trying to exercise control, right? So 2 C's. But again, we're trying to provide a basic, and then again, being here at the International Code Council's hearings, it just reinforces that what we're looking for is a basic uniform method of construction, right? If we have individual state-specific things, that's what we have tags for, and hopefully you're all participating in that process. But as a concept, we should really guide the way buildings are built at a minimum level. And the Energy Code, again, facilitates that by understanding that what we're looking at overall is not what type of energy we're using, but how well we're using that energy, right? And making sure that we're accounting for things like heat loss and control of our interior climates as part of that. I hate the word climate control because it seems to make people think a certain thing. But what we're trying to do in heat loss control and climate control is really trying to fixate on how the building is operating. If you were down here, you'd experience the pain that we're all suffering, where it's 90 degrees outside. You walk into the hearing rooms and people need to wear jackets because it's an incomplete understanding of how that space was going to be used, right? We're not running around doing gymnastics. When we showed up on the weekend, there were a bunch of cheerleaders, and I'm sure they were very energetic. But the problem is we're a bunch of old people, old code officials sitting in a room, standing and freezing to death. And so again, it's understanding how are we controlling that heat and making sure we think about that over the useful life of a building, because we don't want to cost and incur cost or broken equipment because of what we're trying to do. Also, we have the mechanical code, right? The mechanical code is there to help us design a system that helps us to better control that environment. That's the whole purpose, right? It's not a question of how do you hang a pipe. We can figure that out, right? As long as the pipe doesn't fall, then we hung it right. I'm just being facetious. But at the same time, what the mechanical code, the fuel gas codes are trying to do is make sure we consistently provide spaces and systems that are both going to be supportive of our community's residents and our general public. No one should walk into a hotel and feel like they've walked into or out of a sauna, right? We should control that. We know there's windows. We know there are sliding glass doors. And so when we walk into that hotel in St. Paul in the middle of December, from experience, I can tell you, you don't want to be in the lobby for more than 10 minutes because it's not got the right controls for the doors. And so those doors open, they stay open, and then all that nice cold Minnesota air fills that lobby, right? So those are the kinds of things we're trying to prevent against. And that's where I think it's important to think about energy conscious or energy compliant design. Now we talk about, my favorite building is going to be our classic convenience store, because you guys haven't told me there's a better building out there. Everybody's got a convenience store, a Wawa or a Quick Trip or something like that. And so whenever we think about any building in general, though, we have these 4 pillars of energy code compliance: the envelope, the mechanical systems, the fuel systems, the space water heating systems, and the power and lighting controls, right? We have these concepts. And one of those, again, foundational ways we look at it is in that, again, chapter 6 of the energy code. Remember, mechanical systems do a lot of things. Energy code is not the end of it. It's part of the relationship. So not only do mechanical systems provide space conditioning, they also provide ventilation. We also look at, again, data or duct design, not data collection, duct design and proper installation. So we start thinking through this process again. Always think about those 4 concepts: design, efficiency, distribution, and control. The code tells us we have to do it, so it's not like we're doing something special here. We're following the minimum expectations. And again, let's see this played out. I don't want to spend all day talking. I want to spend all day looking at pictures and looking at plans. So one of the first things I think is important, and again, I say this a million times because it is critical to the conversation, is making sure they pick the right code. We know that the Minnesota Commercial Energy Code is not the same as the Wisconsin, the international, any of, or even its own base standard, right? We've made modification, and we want to make sure that the projects reflect those modifications and those understandings. Nothing drives me crazier than seeing somebody come in and bully their way into a project and say, "Hey, we're going to use this code," and then you're like, "No, we've modified it. You didn't account for those," and then it just throws everything off, right? So again, make sure that we're using the right code. Make sure we're using the right compliance path, right? When we see this design and we see what's identified here for us, we've seen this before. And the reason I use the same a lot, same example, is to reinforce over and over what we should be seeing, right? But we should see somewhere in here, in this code summary, a compliance path. I'm not asking for the world. I'm asking for 2 lines, right? I want to know that you know what climate zone we're in. I want to know that you know what the compliance path is. And when you put in this 4.2.11, guess what? You think that's good enough, but it's not, right? We specifically, and if we were to go back 2 slides, we say we even identify it parenthetically, right? We want that in compliance path. We want you to use these words, right? We know what these words mean. These words have meaning. But if we go to section 4.211, all we see is you're building a new building. That doesn't help me, right? I need to know what your path is going to be. Are you going to be following a prescriptive path, which tells you follow the book and only the book, right? Are you going to be looking at an energy cost budget analysis where you're calculating how much does it cost to run this building for a year, right? Which is, when we're talking commercial, is a critical component. It's not just about the first costs. We talk about this in code development all the time and in the tags. It's not just about first cost. It's about everyday cost. I was recently in a town and we were talking about the community development, and we've seen businesses come in and leave. Why? It's not because the community is a bad community. It's because the costs were more than they anticipated. They didn't expect to be spending $60,000 or $20,000 a month to heat and cool, because they were told by their mechanical design professionals that we were only going to have this much. And guess what? It's more than we expected. So it's not financially beneficial. That's how we get a lot of businesses just leave, right? It's not because they don't like the community, it's because they can't afford it. And so that's, again, part of that affordability is looking at the overall long-term carrying cost of both residential and commercial. We're talking commercial, but that residential is always in the back of our head for some of us. That other option is going to be performance. How does it perform? How do we compare? I would argue, and I know I'm going to probably tick some people off, so I'm glad we don't have a thumbs down option in Zoom. But if you were comparing a Ford and a Chevy, or a Ford and a Dodge, there are different ratings, right? You just can't say, well, we picked up a pickup truck and call it a day. No, which one did you get? I know people who will only drive in certain types of vehicles, and I'm going to leave it at that. I'm not going to tell you whether they're found on the road dead or not. But what I am going to tell you is that, again, they're looking for how they're going to perform. They're looking at how they're going to operate. And so we're evaluating what is a Marriott versus a Hilton. What if you were to go to the Hilton family, which, again, not to simplify, to oversimplify, but you go to Hilton, there's a variety of different hotels within that system. So am I going to a Hampton, or am I going to a Garden Inn? Am I going to a DoubleTree? Am I going to a Spark? Am I going to a resort? Which one? Because each one has its own expectation. And that's what we're doing in the performance rating. We're saying it's not about money, it's about grading. And so did you get an A or did you get a B? A B plus or a B minus, right? And if you're my kid, it's probably a D minus plus or D minus minus. Didn't fail, but if they gave it E, he might be shooting for it. We're just going to shut up and move on. I got time. I got plenty of slides and not enough words. So again, we understand there's certain mandatory expectations. And we'll run through these and most of these in this process today, but there are some of these, like we're going to talk about probably not get into walk-in coolers or refrigerator displays, because again, not every project is going to have every component. And so we're smart enough to figure this out, that there are certain things we're going to find every time, and we know what those things are, and that's going to be equipment, distribution, and control, right? And knowing is half the battle. At least that's what G.I. Joe said, right? Knowing is half the battle. So we're looking for that equipment design that equipment efficiency, that control, and that distribution. So let's start into it. We know that we've got a variety of different areas across the state, right? We've got climate 6 and 7. And so we need to make sure right off the bat that our design knows that. Most local designers will know that, but that doesn't mean that everybody's using a local designer, right? We'll go on from there. We'll see some examples of that here today. We're going to see, again, that we've labeled these areas, right? This is the conversation I get into all the time. Is this condition? Is this semi-heated? Well, if it's semi-heated, then I'm trying to isolate it out of my building, right? I'm trying to carve it out so that I'm controlling the condition space, right? The semi-heated, yes, there's some expectations, but it's semi-heated. It's not designed to be as controlled in a space as my heated spaces, right? And so we start to really line out what our expectations are with that and how that exterior wall envelope works within that design. Because again, the exterior envelope is resisting the intrusion of the environment into the building, but it's not doing the same work that we see in a building envelope in the energy code doing, right? We might look at glass as a concept or an exterior cladding, right? Well, that has a function that's different than the insulation in the wall, right? If we're thinking about the shell, let's build a big old building and a strip mall, and we're going to put tenants in it. Well, that exterior envelope of the building is not just going to resist a little bit of rain and snow. We also want it to control the air within that space. And we know they're going to become tenants come in and they're going to do things, but they're not going to be penetrating our thermal envelope, right? They can operate with inside the bubble, but don't burst the bubble, right? It's the same kind of a concept. But we're trying to, again, enclose that space and separate out our condition space so we can control it. Because remember, that's what if we looked at the mechanical code, we look at the energy code, we're talking about control of those condition spaces. Now, obviously, one of the first things, again, compliance path related, are we following a simplified approach? Are we following a prescriptive or performance compliance approach, right? If we know that from the beginning, it changes the dynamic. Just like we saw in that plan review checklist. If I know it's going to be a simplified approach, I change my path. I'm not looking at the rest of the book. I'm only looking at specific sections. So again, understanding that is going to be one of those critical components in the process. And again, I can't hit it enough, the importance of understanding that thermal envelope and the impact it can have. And when we start to see modifications and changes, I've told you about this building before, but again, this is an environment where I had a large warehouse building, and then they decided we're going to throw some offices in there. Well, guess what? Now you're controlling you went from a completely semi-heated space, right? We were expecting big fans to provide ventilation, one gas-fired heater to kind of keep it semi-heated because it was a warehouse. And then you throw in 60 offices. Well, guess what? Now we have to either condition and control the entire space or isolate and separate those offices, right? And again, we're not talking a simplified system. We're talking craziness when you start to do those kinds of things, which is why we need to have as much information in the process. Separating out, again, all these different elements. If we've got office spaces versus work base versus other occupiable space, we would do the same thing with firewalls, right? If we had an office next to we would next to the service base, and then we've got the storage of different chemicals and other things, we're going to have different suppression and firewall expectations. The energy code's no different. If you listen to enough of the code hearings, which I hope many of you are watching them online. If you're not, let me know. I'll send you the link. It's fun to let I always put it on the TV in our lobby at the building at the county building, so that people know what we do, and that we're not just making these codes up on our own. That there's people who are actually intelligent people talking about these and making decisions and recommendations. But when we start thinking about it, these are conversations that we don't always. Again, if you listen to that's where I was going. If you listen to some of the code hearings, you'll hear the energy code brought up several times. It's not on the line of discussion, but it's because we understand that it's part of the system, right? And if you go to the energy code hearing, you'll hear them talk about mechanical systems and about fire protection systems, because again, they all work together to give a building that's going to be efficient and successful. But after we've identified the what and the where we're doing things, and we start looking at the calculations. Now, you know, I always pick on this one guy, Murray. Murray is a great guy. We all have great mechanical contractors that we would trust with many things, but we can't trust him to be the only reason we size something or come up with a design. You have to have a evaluation of that heating and cooling load. The code tells us in section 309 of the mechanical code that we have to have space heating systems, right? This isn't the energy code, right? This is the mechanical code. It tells us we have to have space heating systems capable of reaching 68 degrees, right? And that we're going to be using ASHRAE 62 and 62.1 and 183 to guide that conversation on how we get there, right? If we look at 312, it's going to tell us how we calculate that load in the mechanical code, right? It's not, it's very similar to what we see in the commercial energy code in 6.4.211 or 21, but those numbers, right, are in the mechanical code. That standard that we're saying, hey, we're going to build a building based on the peak load. Yeah, it's not going to hit every event, but it's going to hit 99% of the time. It's going to meet the requirements of that building. And so we have to understand that load needs to be calculated. And we need to see that load, right? We need to verify that that load is appropriate for our community. Again, we've talked about this one before, but if I get a nice little, simplified summary of that heating load, I can still do some evaluation. I can look real quick and see that we've identified this project is in Rock Springs, Wyoming. As much as it might be in the similar kind of place in the U.S. map, it is not the same place that we see it in Minnesota, right? You see, Mark, I see you got your hand up. I'm going to unmute you if you have a question or comment while I drink coffee. Unmute yourself and go ahead. You're unmuted. But you're not talking. Well, I'll keep going. You interrupt when you're ready. Sometimes I feel like I'm a radio star, right? You're on the air with Josh. But again, what we're looking at is, and you might have to log out, log back in, Mark, sometimes to activate the or turn off, whatever to get the microphone to work. But again, we're looking at this design, and it's telling us that we're in the wrong state. So I'm going to send a sheet back that says, hey, your heat calc is for the wrong location. Recalculate, right, for Monticello. I have mistakenly put in my map the wrong city before. Guess what? When I find out I'm not going to Texas and I'm actually going to Ohio, the lady comes on and says recalculating, and boom, I'm in the right direction. Same concept. We can't just go ahead and say, hey, they gave me a calc, I'm good. Yep, I'll put the link to I'll add the link here to the code hearings. It is worth having and going to. So again, one of the things we want to make that comment that says add in the right values. We'll see how that can impact the building here in a second as we go through this. Now remember, I try to keep my life simple because I got too much going on in my brain at times. And so it's like a squirrel, right? So again, I always look at when I'm evaluating a building, first thing I look for is where's my load? What does this building need? Right? And then what am I doing to meet that load? What capacity? Once I have load and capacity, then I'm good, right? Then I can worry about how we distribute it and how we control it. But my biggest two things that are going to cost money and cause problems is the load and capacity in a good relationship. So if we looked at this design, right, we're going back to our convenience store, and we start looking at those cooling and heating loads. We see that, again, we've got 203,000 for the cooling, 228,000 for the heating. But again, what I pointed out before was we were in the wrong area. And so what that wrong area has done, right, even though you might look on a map and say, well, Wyoming, Monticello, they're kind of there, close enough, we're both climate zone 6 or what have you. The reality is we have to look at the design load for Monticello, right? So the median So the goal here in the calculation is that if I'm going to cool at about 4 o'clock in the afternoon on a July day, which is the peak heating temperature according to the smart people that track heating and cooling temperatures across the country, right, across the world. Actually, ASHRAE has a website that you can go to and you can plug in. The code tells us we're using the 2013 data. You can actually, I think it's updated in 2023. Not very, or there's a new update. But again, we're using specific data to say this is the hottest month of the year is generally July at about 4 o'clock in the afternoon. And that temperature should be between 92 degrees wet bulb or 60 degrees dry bulb, right? So 92 degrees, 50% humidity. And so I'm supposed to design a system that's capable of meeting that need, right? Based on the building that I own, the building I'm designing. And so overall, that's how we get to this calculation, right? The sensible load. Remember, sensible load is what we're using to change the temperature. Latent is what's going on in the room, right? These are people in the building put off this much heat and cooling, right? But what we're doing is we're looking to design it. If Monticello is actually at 86 degrees, I'm going to be doing the opposite. I'm going to be over cooling, right? That's a 6-degree difference. If I did this same building in Amarillo, Texas, or Hobbs, New Mexico, that would be 97 degrees. I'd be undersized to cool it, right? So I'm oversizing, I might be overcompensating. And again, that's what happens. But let's look at the real thing that's going to hurt us, our heating design, right? Our heating design is based on a -2 temperature. Well, guess what? We know that Monticello is not -2 at the lowest. The average, according to the math, is a -11. So that's 9 degrees colder than we expected. So you're not going to be able to heat it as well as you thought you were. Yeah, you'll have a little bit of extra cooling, but you won't have heating. And guess what? We all know heating is more important than cooling when it comes to how we survive those long winters in the north, right? And so again, we want to make sure we've got the proper design values. So as a plans examiner, I am not recalculating, but I am going to be looking at what are the design temperatures in my locality, my city, my community, and what are you showing? If you've got the wrong numbers here, I am going to say, hey, adjust your design values and recalculate. Because I need to make sure this is going to work in Monticello, not that it just works somewhere in Wyoming or somewhere in Texas, right? If you go to, I think I was doing a class on New Mexico, their high, it was 97, their low was 11, right? 11 above, you're 11 below. I think it was actually 17. I can't remember now. But, you know, we'd be doing a 20 degrees cooler than a different design. You know, and especially when you're talking about some of these businesses that move around from state to state, they're not going to always remember to recalculate, or at least to send that value to you. So make sure you verify that these values match. These be to existing buildings without air exchange and which uses or changes to occupants that would trigger this addition. So when we start talking about additions to new buildings, that's when we need to, again, do this same calculation, right? If I've got a building that's an existing building and you want to add on an addition, I need to calculate a heating load for that. And then what I'm going to say is I need to, and if someone says, well, I'm just going to add a run to my existing equipment to meet that load, then I'm going to have some serious conversations and questions about whether or not that equipment has the capacity to add that extra load, right? If you can't tell me, then my answer is no. I'm sorry. You're going to do a larger calculation. And that's going to be a frustration for some people. But I do that because, again, I'm looking at how this building is going to be efficient and effective for the lifelong use. Now, if we're talking about air exchangers, again, that's when we start to get, well, maybe we're oversizing. I think we got an example of that, where we're adding, because we understand it's not just, we're not just looking at space conditioning, we're also looking at ventilation. And so we may be in situations where we're adding more air because of the design of a building. So that, you know, if we've got a 10-foot ceiling versus a 30-foot ceiling, well, we're going to have to move more air to do the same amount of work, right? The exterior environment didn't change, the interior design doesn't change. but the building itself changes. And so maybe I'm adding extra components to add in additional outdoor air maybe there's the HRVs and ERV systems, right, that we're incorporating into our designs. They're all going to come into play to evaluate how they're impacting these components. And sometimes that's one of the things I think is important, is that we don't just go with a summary page. I'm sorry. I like to have a little bit more detail than this because I want to make sure that everything is consistent. Summary pages can be helpful, but I think as we start to refine the building code, you're going to see in some of these examples we have here in a second, how that summary page is not going to be enough to document that this building is getting what it needs and justified some of the size of the equipment. And so in this example, right, so we moved on. I think the question on exchange rates is really more, it's part of its occupancy, and some of it's going to be based on the design, right? We've got questions about how do we meet that load and that ventilation requirement with the same piece of equipment, right? And one of the things that we see lose consistently, as we'll look at here an example, over time we see lose consistently is this oversizing consideration, right? And so I think we'll see if we can answer that question here in a slide or two. So again, we've got a load that we know, we've got equipment that we've identified, we can calculate how much is coming out of it as far as the capability of the equipment to meet the load. And so we add it all together, right? We have a load of 22, we have a capacity of 346, a load of 201, and a capacity of 248. So we're exceeding, right? The code generally just says you have to meet the load calculation. Now, ASHRAE, if you looked at the evaluation resources for ASHRAE, they'll tell you can go up to 2 times the size of the load. Because again, we understand we might need more air because we're making a tighter building. A good standard is going to be 25 to 40% of load. A lot of times we'll talk about going a half size bigger, a full size bigger than what's the requirement, because we want to provide a little bit of cushion, for that equipment. But that's the reality. Is part of that is trying to understand what is it we're trying to do. We're trying to move air, or we're trying to condition space. And so a lot of times we have that conflict. If you look at the system, the reason this system becomes so large is because of the CFM of air it's trying to move. Because it's looking at, we've all been in a convenience store, and we've all seen that 14, 15, 18-foot ceiling that we have in a convenience store. Well, that requires a different amount of air movement than an office building with a 9-foot, 10-foot ceiling. And because of that, that's why we have to compensate differently and pick different equipment and evaluate. And I think that's one of those conversations. If I know you've done the math, I know you've evaluated things, I'm not coming back and saying, well, if I go to that evaluation, I see you've got the right design, that you've calculated the airflow requirements, the ventilation requirements, then again, I'm looking at that equipment to make sure that you've selected it. You haven't gone this far to pick the wrong piece of equipment, right? And so again, we see here we've got a load and a capacity for this convenience store. And then we're also looking at everything else that goes with it, right? We can look at the gas pressures to make sure it's going to match with what we're doing. We see this a lot of times, especially when we start adding or reconditioning or modifying conditioned spaces or changing the design or changing equipment, is we were designing a pipe that could handle this size of equipment. And then we come back and say, well, we decided to upgrade. Well, did you upgrade the pipe or just the equipment, right? And we'll talk about that in the context of it too. But one of the things that's happening in this process is, again, we've identified a load for heating requirements. We've identified a ventilation requirement. Now we're selecting equipment that matches that load. And so if I start to look at that table, we've got these 3 different sizes of equipment that all provide the same level of heating output, right? They all provide the same BTU. What they change is when we start talking about the airflow, right? Our airflow rates change. And so if I'm looking for airflow rates, that I'm going to select a different piece of equipment. And so that equipment might be bigger because I'm looking for a different airflow. And again, part of that is going to come back to the duct design. So you can't look at one piece individually and say, this is the culprit for the entire complex or project or the system, right? Because we know that if I put in a square duct versus a round duct, I'm going to have different friction rates. And so I'm going to lose pressure over time. If I throw in some flex line, I'm going to have different pressure changes. And so we have to look at the whole system. And that's what frustrates me as a building official or as an inspector in the field, because you design this system to work based on X piece of equipment. But when we get out in the field, because we didn't document the design properly, I now have flex duct where round duct was designed. Well, yeah, it's still a circle, but it's not a circle that we're looking for. It's the interior surfaces and how they affect airflow. So we're not doing that air modeling, that velocity monitoring to say what is hitting, how much air am I getting into this occupied space or this habitable room, right? And that's where it's important for us to calculate. Most of the rehabs I'm seeing, especially some of those change outs, all come back to airflow. Their bigger problems are airflow than they are, heating and cooling loads. But because of that, we're having to size things and document that's the reason. Because what happens, and I will tell you this has happened recently for a jurisdiction that I know was, and I may have already talked about it, but if I did, too bad. We always get new people in these classes. So one of the conversations that we had was, the city approved a design based on a proper calculation of the heat and cooling load, proper equipment, proper layout, proper everything. Everything was installed the way it was supposed to be installed. But when they get a friend that comes over who has a mechanical engineering background, they said, hey, I think your stuff's too big. And so that turns into a conversation that, their buddy goes and recalculates what he thinks the load should be, shows it to the homeowner, or the homeowner then calls the city and says, the county and city says, hey, I think you guys screwed up here because I've got a second opinion and my load is different. And part of that comes back to, well, did they look at the right piece of equipment? Did they look at the right design loads? Did they look at the right, airflow modeling and the right distribution duct systems? No. Well, then you can't compare apples and oranges. And a lot of times what we see is, especially the first thing that happens before a business, again, we've talked about these on large scales. If I'm expecting a $20,000 a month expense for operating costs and I'm getting 60,000, the first thing I'm going to do is call another engineer, call another mechanical person out and say, evaluate this system, tell me what's wrong with it. And if it comes down to, well, they were supposed to put in round duct, but they put in flex line, and so your system is operating twice as hard to get the air to the right places to change the temperature, then that comes back to somebody in this circle, to who is supposed to acknowledge or identify that. Is it always us? No, but it is. We are part of that system that gets blamed and questioned and gets those public FOIA requests on everything we've ever done in our lives, right? So again, digression, I should probably move on. But again, we need to select equipment based on not only the heating load, but also the air exchange requirements, the airflow requirements of those buildings. And then once we've selected that equipment, we've calculated a design for both mechanical and ventilation. Then we actually we picked the equipment that would meet both numerically. Now we start to look at how efficient was that equipment. This is the part that to me is the easiest, right? Because all I'm doing is comparing a piece of equipment to a table. That's it. I'm looking at it and I'm saying, hey, they've identified RTU3 here. RT3 is going to be serving the kitchen. It is 2,000 CFMs of air. It's going to be 130,000 BTUs. It's 80% efficient with 80% efficiency is its proposal, right? Simple gas-fueled furnace, duct furnace in the roof. So I go down, I find my table. We know that there's 20 tables to look at. I find the right table. I find the right size. I scroll over and I see 80%. Guess what? Beautiful. I'm done. That's the easiest part of this whole process, right? I go to the next part of that equipment. I see that here's the cooling. I look at that size. I look at the capacity. Go to the right table. Verify that I've got the right zone, right? Cooling systems is where I usually see the most problem, because what we're starting to see is that the value, the unit of measurement has changed several times in the last 5 to 10 years. And so we've gone from SEER to EER to IEER to SEER2. So there's a variety of different ways we can measure it. And so what we see in this example, they're telling me I've got a 15 SEER system. I'm supposed to have before an 11 IEER before 2023, maybe a 14.8 after 2023. But that IEER is not a SEER, right? They're different measurements. That's like saying pounds and ounces, or dollars and rubles, right? Well, they're not the same. So you can't just say $1 equals 1 pound, or $1 equals 1 peso, or what have you, whatever unit of measure. You have to correlate the two. So I usually ask for clarification. I'm not going to sit there and do that math. I'll be honest with you. I send a note back to the designer saying, hey, I need you to identify this in the appropriate unit of measure. I want SEER2. I want SEER numbers. I don't want these other values that you're providing me, right? And so again, I'm going to go in, I'm going to say, hey, I need these corrected to make sure they reflect the appropriate unit of measure. And then I'm also going to identify that, well, while I was looking, I see we identify a 15 SEER system, but you identify a 13 EER system. So wait a minute, is your ComCheck right or your details right? You figure it out and get back to me. Because what's going to happen is when I get in the field, I'm going to have that kind of confusion. Well, the plan said this, but they installed that. Why? Because it's in the plans, right? Same thing when it comes to the size of the equipment. I need to make sure that all this is there. Because remember, knowing what's right is only half the battle. We also got to make sure it's done right in the field. And we are in this together, right? G.I. Joe didn't operate by himself. This is G.I. Joe Day. He didn't live by himself. He had, was it Mary Jane or was that Spider-Man? But anyhow, he had teammates with him, right? It wasn't just him. And so again, we need to think about the other side of this equation, which we'll be talking about next week. We'll talk about inspections. But not only that, but we also, again, we've gone halfway through this, and so we need to finish this out with distribution and control. Because it's not enough just to have the right equipment, you got to actually control it and send it where you want it. And so when we start thinking about those controls, what are we looking for, right? We're looking on those notes and saying, okay, we've identified the control. We've identified where it's located. What is its function, right? What are those actual functional controls? And we find that a lot of times either in sequence of operations. That's usually where I like to see it, not in the spec book, because the spec books can tell me everything it can do, not what's being told to do. What it's being told to do is that we're going to provide these different levels of control, right? So I'm going to read through them, make sure that I'm getting the appropriate expectations on temperature and setbacks and off hours if we're going to have them, those types of things. Convenience stores are probably going to not have a lot of that because they're going to operate year round or 24 hours a day. But some of those other offices will have those kinds of control issues. And again, so we've got the controls. Now we start looking at distribution. Remember, we start talking about the mechanical code and the energy code. The energy code, what do we know about mechanical design? If it's outside the thermal envelope, it needs to be insulated. Wow. That's like mind-blowing, right? No. We've got an entire section of the mechanical code that tells us how to design these systems, right? When we're looking for controlling condensation, because remember, that's ultimately what we're trying to do, is trying to prevent condensation inside our duct systems because we don't want to be pushing that bad air through our building, right? If anybody's ever had a situation where a panel has gotten dirty or nasty, and I've had this happen in a few buildings I've been in, and they turn on the air handling system, and all of a sudden this cloud of junk goes flying through the air, right? That's because it's a dirty duct. And the reason it's dirty is because we're getting condensation and getting nasty, in that area. So again, make sure it's properly constructed, properly insulated is a function of location, right? It's a conversation of, is it in the right spot, right? Is it inside that building thermal envelope? Over and over, we talk about it all day long, the relationship between the two. If I've got ducts that are inside that envelope, I'm not insulating because they're going to be part of that conditioned space. right? We see some notes down here about that. Here we've got, again, more notes explaining when they're going to be lined with some type of insulation. Again, because they're looking at it from a condensation, air inflow and outflow, right? They're not required, but they're going to insulate them so that, again, we don't have condensation accumulating inside these air handling systems. Again, there's our examples again of duct design. We need to know what's going in and how we're going to protect it against things as simple as UV rays, right? I've got some lines going from to a condenser, and so I want to make sure that they don't get damaged by UV rays because they're exposed to the weather all year round. And so again, very simple. Now we see that a lot of times with pipes. We can have a whole conversation about protecting of pipes for both fire systems and other systems. But again, we understand what we're looking for some level of protection and insulation for pipes as they are a part of our space conditioning system. Now, we're going to have a class probably in June talking about plumbing and the relationship between plumbing systems and the energy code. It's going to be a little bit more, I think it's fun. But again, when we think about it in this context, we're looking at it as a space conditioning system. And so when we talk about ventilation, again, the code tells us we need to ventilate, right? So again, this is part of that consideration that goes into the design. I see, again, the relationship between mechanical worlds and energy relationships not that far apart because, again, they're the same system doing both functions. So we can look at them together to make sure we're meeting those expectations. Most of us don't use open windows as our means of natural ventilation. I think there's even a push in some, I think there's I can't remember if it's a conversation, like a code proposal, or if it was actually, I think it was just still a proposal to remove the concept of natural ventilation. Because let's be honest, if you're living in Duluth, you're not naturally ventilating in the latter half of the year, right? So again, we need to think about that and be realistic in what our expectations. Most of us don't work in buildings anymore that have openable windows, right? The closest we get is that door opening, and that's usually a bad sign because that means people are coming. But anyhow, I'll digress. So again, we're looking at how they comply with the table 403.311 or 1.1 or that approved engineering analysis. Because again, just because we have a table doesn't mean somebody's not going to say, hey, I got a better idea. Okay, go with it. Show me what you're doing. Show me your work. It's like school, right? Do your math, but show me the work. So again, how we're classifying those areas, calculating those outdoor air ventilation schedules, and again, making sure that equipment is capable, right, of meeting those requirements. In addition to our exhaust fans, remember what we're looking for in those types of controls. Fans is to, again, what kind of controls do we have, and what kind of size motors are we running? So that, again, we're not constantly running a system that doesn't need to be constantly running. So we got some air balancing tables that go with this design, right? What is RT1 doing? What is RT2 doing? So again, like I said, this is when we start finding equipment that's going to be a little bit bigger, maybe because they've got air control where they've incorporated other air components, system components, and so they have to provide a little bit more pressure to get through those duct systems and runs. There's our sequences. Just a quick reminder that the mechanical code doesn't just address the duct, but it also will address some of the fuel systems associated with equipment. And so again, we have to make sure we're properly sizing our equipment to meet those loads and making sure we have those calculations done properly. I know I've got a few more slides I want to get to. Real quick, just a reminder that all of this, again, builds on this concept that planning facilitates inspections, right? The plans examiner is not the one in the field. He's the one in the office. And so they got to be clear and have adequate detail so that the inspector and the installer in the field are doing the right thing and identifying up front what testing or what commissioning is required for a building. So let's look at a couple more examples of some buildings. So here's a very simplified, very, very simple design, right? You would think just a big block building. And so what we find out is we've got a system, right? This is all that I'm showing you, all the details received in this plan, right? So this is the drawing, and this is all of the information One thing I miss, and maybe you saw it, but I didn't see it in those 3 slides, was any type of load calculation. I saw that you identified equipment. I see that you gave those equipment some controls, right? The 7-day programmable control, auto changeover, right? Appreciate that. You got exhaust, you calculated. You even got equipment sizes, right? You got some SEER sizes. We have efficiency ratings. But what you didn't do is tell me how much air is your building need. I mean, I get air. I see some CFM markings, but there's no heating load calculation. How do I know that this piece of equipment is not 500 times bigger than what you need? So this is a simple, please provide the heating load calculation and associated documentation to verify the equipment meets the requirements of section, and then I would give them the code section. 312 point or whatever. Similar example here, again, another one here. Again, we're not using the rule of thumb. There is a rule of thumb that exists. If you looked at the ASHRAE Book of Fundamentals, you talk to contractors. You know, if you go to MapMo, go to an engineering conference or chapter and start asking this question, and you will get 57 different ideas on how to size a building, right? Because that's the reality. We all have our own way. And the problem is we need to actually get to where we follow one way, right? And so one of the things we need to do is not go by these rules of thumb, but actually start calculating those designs, right? Calculate the heating load so that we can figure out what's the appropriate equipment that we're going to need. So this one here used a design that provided both in a combined versus separated systems. So that again, we figured out if we have one system that has redundancy, then how do we demonstrate that, right? And again, this is something where I had conversations with the designers of this, and we talked about if we need to understand the redundancy so that we don't have this one direction mindset that says, wait a minute, I see you have 200,000 BTUs of need, but you're giving me 300,000 or 500,000 of capacity. Why? Well, let's talk it through and let's have that conversation. Give that in the notes that explain that you're providing redundancies based on the type of occupancy. And most of us don't see a lot of it like this, but if you got hospitals or you have, again, police stations or some types of senior living facilities or prisons, they need that redundancy. We don't just get to let the people out because, hey, go home for a weekend because we ran out, the equipment broke. We have to keep them there. And so again, thinking about that redundancy is part of that conversation that we see in that line. And then again, having those controls. That's where we put a lot of that in the spec book, and we recognize the spec book in that process. When these things are not working, how are we going to have the RT1 shut off, but this other system takes over because of the different redundancies as part of the system. Just want to remind us about, again, fans and those kinds of things. They show up once in a while, not in every building. So again, that's why we can look at those. And again, our convenience store, we need to look for, again, those scopes of work associated with refrigeration. Here's our air barrier, here's our beer cooler, here's our beverage cooler. And so they're going to have insulation associated with those refrigerated spaces that are not going to be the same as the wall. The exterior wall has its own insulation requirements. We can't say, well, because the beer cooler's there now, we can reduce the insulation for the rest of the building's life. No, because that's not how that works. Again, here's another example of one I think we may have talked about in a university who decided to follow the performance rating path, right? They weren't going to go with give me a prescriptive path. And so they're actually calculating how much does it cost to run this building, right? Here's our baseline building. It's going to cost us $40,000 to run this building. And after all the things we've incorporated, the different wall designs and equipment selections, we're going to go down to 21,000. We're going to save 44% of the cost. Well, again, if I'm the institution and I'm expecting it to cut a check at the end of the year to cover $21,000 worth of expenses or fuel expenses, and it comes back at 40, I'm going to have some conversations. Why were we double what we expected? What was the point of all these cost saving measures if they didn't save any cost, right? And it all comes down to making sure we understand how it's designed. right? Going, and again, this is an example of, and we'll talk more about compliance pass in a couple weeks, but again, looking at how this is the baseline design versus the design, right? The base reference standard versus the design. All the different things that we've incorporated and added, right? To show this is how the building is going to be designed. This is how the building is going to operate, what our expectations are for average versus peak daily occupants, right? If you've been in a classroom lately or in a college especially, they're not all there at the same time, right? And again, the same thing happens in our offices. We have conference rooms that have peak loads, peak occupancies, and then you show up and then you sit in there and eat your lunch. So again, you're using it, but not to the extent that it was designed. And so this design laid out all of the different room calculations, the number of CFMs, the amount of heating and cooling it needed in order to come to this calculation. This made me confident. I did not run through and recheck every line. This gave me that level of confidence that they're going to evaluate. They've evaluated all these rooms. They've evaluated the airflow, evaluated the requirements for heating loss in each of these rooms. So when we talk about this one here specifically, this one here's specific to ventilation, they got into section 2.2 over here at the top and the overhead lighting and daylighting controls. They got in here, we have task lighting and heat gain associated with different equipment, occupancy, expectations and the impact on infiltration and heating requirements, the zoning of the systems, the assemblies as they were designed. All of this, again, gives me that confidence. I'm not recalculating anything as a building official, as a plans owner. I'm evaluating, did you go through the work? Did you do your part to evaluate? And then they give me, on top of that, they gave me comm checks to expedite the plan review. Because they said, hey, we're doing this so you can see our equipment matches. So I can run through, like we said, that fastest part of the process where I can say, look, they've identified a ground source heat pump. I look at a ground source brine to water heat pump in heating mode, and this is the rating I'm supposed to give it. And then when it goes to cooling mode, it's a 2.1 EER and it's a 19.7. It exceeds my expectations, right? We can look at that long list of equipment they've identified. We can zoom in, we can see they've listed all of those heating, those coefficients of performance, those energy efficiency ratings, and that they matched what was on the comm check, right? So again, making sure everything matches in that design so that at the end, when I start talking about all these pieces of equipment, it's a lot faster. It takes me less time to do this large school than it did to do the police station because they gave me all the details up front, and that it makes plan review that much faster. So then we can see all those controls and those distribution systems. All that can be part of that, understanding ventilation rates and how they're being, again, those designs. That's all part of this system that we think about when we think about mechanical plan review. And like I said, we're going to put together some other things to help facilitate this conversation moving forward. But again, it's all about calculation, equipment, distribution, and control. Now, I know we got we're right at time. So if you have questions, feel free to pop them out or throw them up. Remember when you put in your survey, give us some topics for the upcoming trainings. Right now, we've got plan review for today, inspections for next week, get into compliance paths, kind of do an overview of those compliance paths, get into interior lighting. Right now, we're scheduled for another Bring Us Your Energy Code questions. We may also bring in some special speakers, as well as we'll get into the power lighting systems, plumbing systems, and documenting energy code compliance. That's where we're going to talk about commissioning and some of the things that we're getting as far as documentation, both at the beginning and more importantly at the end of the process. I think our plan review is hitting maybe more so going to hit more so the front end of the documentation, but the back end is going to be the focus of that class. But again, if you have any additional training that you think would be helpful, please let us know so we can make sure we schedule those. We do have that upcoming in-person conversation with Jay Crandall, who's here at the code hearings, regarding the different installation and impacts of insulation materials for both continuous and bad insulation. They don't work for specific institutions or manufacturers. They're giving more of their experience as recognized experts in the area of insulation. And so if you do have any questions or if you need a little help throughout the process, please feel free to reach out to us if there's a question, a com check, or something we can do to make your lives easier, we're here to do that. You can always reach out to us through the website or through our email, mnecsp@trumscoda.com. Did you cover this class earlier this year? We talked about design earlier. We talked about this in a very high level, probably at the beginning in January. But yeah, this is the first time we talked about plan review specifically for mechanical this year. So you guys have a great week. Be careful, be safe. I'll try to do my part to send back as much warm weather as I can with the guys as they go back. But I'm just telling you, it'll be fun. So if you guys have any questions, let me see. I will email out. If you stay on, let me get this email address real quick. ICC safe. ICC safe. Here's the website you can go to. And if you go on, you can actually use it to watch some old ones as well. I'm pretty sure that if you go to track 1, wink, wink, nod, nod, track 1, you might see some staff members and local, I'm now calling them local celebrities online. So feel free to check them out, though. It's a great time. So you guys have a great week. Be careful, and we will see you soon.